case. I attempted to print 3 out of flexible filament, or 2 of these out of flexible filament. The first one came out okay. Second shot, it kind of died halfway. Like I said, my printer has serious issues with flexible filament, so I decided just to try and get some, sizing prototypes out of PLA, not flexible. This one, the wall thickness had an issue, and I worked that out. So you can see I have solid walls on this next one. So that was an issue with my open SCAD equations. Fixed it. You can see the little tiny buzzer hole there. Then I had a print that just failed. The bottom is separated. Well, this is facing up. When I pull it off the board, the bottom is separated. And finally, this one, which came out pretty decent. So this isn't a completed board, but we got the buzzer, solar charge. This is actually a revision 4 board, so it has the separated battery protection IC and charge circuit and micro USB. You can see the collar will loop through here and here. So you can see it's plugged in micro USB. The charging port fits rather well with this. Let me grab something to demo the threading of the collar. Okay, so I have Japser's little collar. You can see how this would work is. And we have a problem. You can't use the hard case because the tin doesn't fit through it. So that's going to be something to consider. Instead I'll use a soft case. Should be able to still get it through here, so the board would sit in there. And just pop it through the top. Yep, soft case works, so pop that through the top. So with the flexible filament, it's not a problem. Then that would just conform with the collar to the curve of the cat. So let me buckle it up. So pretend my wrist is the cat. Let's see if we can get this on. So we got Japser's name there, and then we rotate it and we see the curved case. And that'll have one of our prototypes sitting in it, which will also curve to conform. And then on top of the prototype, black solar cell. That's what we're looking at right now. Obviously, since I can't bend this one and the thing won't pop through, I can't show that right now. Now here is the alternate design. Just using a piece of really thin PLA. You can see it's very flexible. That sits on the cat's neck. It's already curved, so it should conform rather well. This one has an alternate battery. This one's kind of thick. This is a 5mm thick battery. I'd be using a 2mm thick. Solar cell's just flexed on there. The board's on a different section. Got the radio there. Would you look at that? My timing is impeccable. Okay, so I happened to scan just as it was broadcasting. And I don't know if you can hear the beeping. But it works still. So it's been 1 week on the Better Life, 7 days so far. Still working strong. I'm going to put this on Japser's collar. Now, the final design for this would also involve holes, but since I didn't print it with them, I will be using electrical tape to attach to the collar. So this has been off Japser for a week. Now I'm going to install it to his collar, and we'll see how it does on Japser's collar. See if it keeps broadcasting. So now just a quick check to make sure nothing went wrong. While I was installing it, which you shouldn't have. Oh, look, it's still there. So I will go put that on Japser, and I'll have my cat Bluetooth low energy cat monitoring device listening to make sure it doesn't skip any beacon periods. Okay, I just wanted to get in here and show you a couple other things with the new case. First of all, you can see this edge. Get in there with some tweezers. When I printed it, this last layer, that the solar panel is supposed to fold under, fuse down. So I separate a little bit with the tweezers here, but you can see there's spots where I can't get in. So that's where the solar panel is supposed to be able to slide right in, just like that. Kind of gets in there on the left side, you can see. So that's obviously that's going to be a problem in printing. I might have to stop at the top layer of the print, insert the board, insert this, and print over this. That might work. Still have to try that out. And I want to show you inside. So I thinned the board, but even on this one is not quite 18 millimeters thick, which is the thickness of the battery I was planning on using, and I'm thinking of moving away from that. So you can see right here, I have space. There's a fair amount of space between the buzzer and the wall. So if I did waterproof seal this, there's this big air pocket. So I'm planning on bringing this down so it's 15 millimeters across on the inside. And then I can, use a waterproof connector here and seal around the edges. And use another, and then jam this against the edge and seal around where the front meets the side. So put a little bit of sealant on the front of that connector, jam it in there, and I should have a waterproof seal. And of course you can see under here, you can see that there's a little bit of a lip there. So the solar panel will slide under that lip. And a layer of sealant across the top of the solar panel will hold it in there. And of course a layer of sealant here on this edge underneath the solar panel. So we'll see how all that works. And I'm thinking of changing the battery to instead sit here. So we have the micro USB to the edge of the case, kind of a 12 by 12 millimeter battery, 2 millimeters thick, should fit right in that pocket. And that's how the case design is going right now. Okay everyone, just wanted to give you an update. This is revision 7 now that we're looking at of the SolBLEtracker, so revision 7, and I updated it to be 2 layers now that I'm going with professional PVC manufacturers instead of making them here. Right now, just to let you know, the Flex prototypes from Flex PCB will cost me $850, so I'm holding off on that for a bit, and I'm validating this design on a 0.4 millimeter PCB from PCB Cart. That's only going to be $100 and you get 50 of them. As far as the Flex PCB, I know there's some cheaper options out there, but the quality is somewhat lacking from what I've researched. IT Studios that has that $90 Flex turn service, but from what I've read and seen, it's not that great. Plus I want to get the prototypes from the place that I'm going to have do the production run, because, well, then I'll know exactly how it'll turn out. So you can see the orange kind of areas here. These are the rigid or the reinforced sections of the Flex. Reinforcement here is primarily because of tearing on the micro USB connector. If it gets twisted, I had that problem with the R3 and R2 prototypes. So just by distributing the load along a longer area, it'd probably be fine without it, but I figure I'll have it made with that there anyway, since because of the micro USB, it's not going to be flexible very much either. Then we have the 2-volt buck converter that saves you a few microamps of a little bit of power there when you're going from 3.6 volts of the lithium-ion battery down to the 2 volts this device uses. That's probably not going to be populated in the final version. I think with this short bursts, it really isn't going to make a difference, and it's not worth the chip cost. You can see I moved the LED down closer to the edge. This way, if I do put a hole there for seeing the light, it'll be a nice short trip for the light pipe, plus the solar cell will run mostly along the middle. So I might just be able to put a hole straight up, put some hot glue in there, and that'll be a light pipe for it. So we'll see how that comes out. And I tightened up, so it's thinner. There used to be a trace here. You can see it's on the bottom side now. The trace that controlled the reset. So the reset line was here, and it had to come out the side. Now it's going underneath the board. And that brown bit, that's all ground plane now. So on the bottom, put my logo and the name of the board. It's where there's space, since it's totally unpopulated. And we got this nice ground plane, which should improve RF performance in addition to what we got going here. I thickened all the traces that be carrying most of the power to the buzzer, up through to the radio. It's probably not necessary, seeing as we're only pulling maybe a couple hundred milliamps to the buzzer, 30 milliamps to the radio, but I figure I may as well if I have the space. Like I was saying before, I brought everything up. So now this board's only 15 millimeters across and about 42 long. So for batteries, the one I'm working with right now is 18 millimeters by 40 millimeters, so it goes from about here to the antenna, and it's a little bit thicker than this board. This board's 15 millimeters, so it comes down 3 millimeters. Now, since the batteries aren't quite as flexible as I had hoped, you know, they kind of got a metallic property where you'll bend them and they'll stay in that shape, and I don't know that I really trust them to flex multiple times. So I'm thinking to go with maybe, like I was saying earlier when I was showing the case, at 12 by 12 by 2 millimeter in this section. Shouldn't really affect the flexibility. It's mostly going to bend here and here. And this will be solid, this will be solid. With the battery here, it'll be mostly solid. Might bow out a little bit. So let me just show you the batteries I've been looking at. I've been looking at Power Streams batteries. They're the only ones that I can find that make really thin batteries. And this is the one I'm looking at, the 2 by 12 by 12. The one I was using before is this 0.5 millimeter by 40 by 18. And, you know, it's just not as flexible as I had hoped. So I'm going to order a few of these, probably a couple more of these just because I'm out. I might try a couple other sizes. And I'll put them in the cases once I get them printed up, and we'll see how they work. See if they survive field testing on the cats for a few months. Changes to the case design. Really, well, first of all, I fixed the position of these holes. I had them reversed. They were on the flip side. So that's fixed. The other thing, I thinned the top and the bottom of the design. They were 1.5, now they are 0.7. My equations were wrong for the walls on either side, here or here. So now that's thinner in that direction. Everything else is pretty much the same. So this is Jasper, and he's getting his tracking collar put on for now. So Jasper is now emitting Bluetooth.